Welcome friends to the another session on digital electronics. In this session, we'll be discussing about one of the most commonly used binary code, and it is being known as ASCII code. In this session, we will understand what is ASCII code, what are the features of ASCII code, and how ASCII code can be used in our data storing. So friends, as you know that you are viewing this session on my YouTube channel, Learn with Prakash Kanade, and do not forget to subscribe to the channel. Friends, as you know that in our real world, the data can be in variety of forms. For example, our data can be in the form of text. Our data can be in the form of number. The real life data can be in the form of image. It can be in the form of sound, or it can be video. You will find that depending upon the type of the data you have, you need some input device to read such data, and through the input device, you can feed such data to the computer system. And inside the system, when this data is being stored, some of the standard is being used for storing the data in the sequence of zeros and ones. You will find that the BCD, we have already seen the BCD code and gray code, but the most commonly used code is the ASCII code. And this is the code that is being commonly used for storing the characters into the electronic devices. You will find that ASCII code is an alphanumeric code. And by using those code, it is possible that we can convert letters, digits, and several other control characters in binary form. That is almost any symbol that is being available on your keyboard can be converted into binary form by using ASCII code. This word ASCII, ASCII, actually it stands for American Standard Code for Information Interchange. You will find that from this word American, A is being taken, S is being taken from standard, C is being taken from code, I is taken from information, and the next I is being taken from interchange. So ASCII is a short form, and its long form is American Standard Code for Information Interchange. So you will find that this code is being prepared by American National Standard Institute, ANSI. And the document of such code is being available, and the document is being labeled as X3.4-1977. Now let us see some features of the ASCII code. You will find that ASCII is a 7-bit code. So it is possible that by using this code, we can convert or we can represent 2 raised to 7, that is equal to 128 different symbols into binary form. Suppose you have been given only 1 bit, then you will find that by using 1 bit, you can represent 2 symbols. If you have been given 2 bits, then it is possible that you can represent 4 symbols in binary form. Similarly, you will find that when you have been given a 7 bits, then by using such 7 bits, we can represent 2 raised to 7, that is equal to 128 different symbols in the binary form. This code, you will find that basically consists of 2 types of codes. The first type of the code is being called as a graphic code, and there are about 95 different symbols or 95 graphic codes that are available in ASCII, and these graphic codes can be easily displayed on the console or on your monitor screen. Apart from the 95 graphic code, you will find that the ASCII will contain some 33 control codes, and these 33 control codes are required for feeding the data, but they are not displayed on the console or on the monitor. Now, this is the complete table of ASCII code. You will find that this table will consist of about 128 different symbols. And for each symbol, you will find that there is a binary number. This part of the code or these bits of the code are being called as the most significant bits. And this part of the code or these bits of the ASCII code, they are being called as the least significant bits. Say for example, if I am writing a letter A, capital letter A, then for this letter A, the ASCII code is 100 because this is the most significant bit, 1000001. So this is the ASCII code for the letter A. Similarly, for the letter B, the ASCII code is 100 and 0010. In this way, you will find that for the letter Z, the ASCII code is 101 and then 1010. You will find that there is a separate code for capital letters and there is a separate code for small letters. Say for example, if we have a small a, then for this letter, the ASCII code is 1100001. Similarly, for small b, the ASCII code is 110 and then 0010. So the most significant bits are to be referred from this place and the least significant bits are to be referred from this column. Similarly, you will find that whenever we have a number 0, then for this decimal number 0, the ASCII code is 0110000. Similarly, for decimal number 1, the ASCII code is 0110001. And in this way, for decimal number 9, the ASCII code is 0111001. So you will find that almost all characters that are frequently needed for feeding the data to the computer system, all such characters you will find that can be easily represented in binary form by using this table. So we have all the letters from A to Z, all the numbers from 0 to 9. And apart from that, you will find that several other symbols such as colon, semicolon, less than, equal to, greater than, question mark, comma, opening of the bracket, closing of the bracket, then dollar sign, hash sign, and sign, all such keys which are normally available on your keyboard, you will find that they can be easily converted into binary form by using this table. So as I said, this part of the code, this is being called as a graphic code, or these are the 95 graphic symbols and they are displayed on your computer screen or monitor screen. So whenever I type this symbol at the rate, then you will find that actually in ASCII form, it is stored as 1000000. So 100 is being taken from here and this 0000 is taken from here. And similarly, you will find that whenever I have a letter capital P, then for this the code is 101 and 0000. So these are the 95 different symbols, and you will find that all such symbols are easily displayed on the screen, and therefore this part of the code is being called as a graphic code. Apart from that, you will find that there are some other 33 codes, and these codes are being called as the control codes. Say for example, DEL, delete, and this sequence is being called as a control code. So in the control code, you have null, you have SOH, STX, end of text, ETX. Then you will find that there is a symbol like bell, then backspace, BS, horizontal tab, then line feed, vertical tab, carriage return, form feed. So there are different control symbols. You will find that these symbols are also needed whenever we type any data on our computer system. And whenever you use such symbols, then you will find that for such symbols, such code is being converted or stored into the computer memory. Say, for example, when I have a backspace, when I use the backspace, then the data that is being stored in ASCII form is 0001000. Similarly, when we use this delete, then the ASCII code that is being stored is 1111111. And you will find that for null, the ASCII code is 0000000. So you should find that actually the code for decimal 0 is different and the code for null is different. We will see some of the control codes in the next slide. See, 0, it will stand for null. Null, you will find that in some programming languages, this null is being used to mark the end of the string. Then you will find that the code 7, that is for bell. So whenever you want to say ring a bell, isn't it, something like a warning bell or beep, then this code is being used. Whenever you use the backspace, then for the backspace, you will find that we use the decimal 8. And whenever we use the backspace, it means that we will go to the previous character. Horizontal tab will move the printing position to the next tab, stop. Then the line feed will move the print head down one line. Vertical tab, you will find that this is a vertical tabulation. Then the form feed, you will find that will cause the printer to eject the paper. Carriage return will move the printing position to the start of the new line. So for the carriage return, you will find that the code that is being available in decimal is 13. Similarly, whenever we press the escape key, then you will find that for the escape key, the decimal code in ASCII is 27. Now let us see one simple example. Suppose you have been given a string hello world. And now we will see whenever we type such words hello world, then you will find that when they are stored in the computer memory by using ASCII code, then how exactly it is being stored. So this is the H, and for H, if you refer to the ASCII table, you will find that the code is 1001000. So it is a 7-bit code, and therefore I will add one more bit to the most significant bit position so that it will be an 8-bit code. So when I convert this number, binary number, into hexadecimal, you will find that the hexadecimal for this H will be 48. Or when I convert this hexadecimal into decimal, you will find that the decimal 72 number will be stored in the memory whenever you type this letter H. Similarly, whenever I type the letter E, then the ASCII binary sequence is 01100101. So in hex form, it is 65. And when I convert this into decimal, then you will find that the number 101 will be stored as the letter small e. So you will find that in this way, we can compute the decimal equivalent for each letter that we type in this string of hello world. So whenever we have some comma, isn't it, then there also you will find that the binary sequence is 00101100. So when you convert this into hexadecimal, it will be 2C, and when you convert it to the decimal, it will be 44. So whenever you use comma in your text, then always remember that this comma is not stored as it is, but instead of that, the decimal number 44 will be stored into your computer memory. Similarly, you will find that when this letter D is used by us, then the binary sequence is 0110 0100 its hexadecimal equivalent will be 64, and when you convert it into decimal, it will be 100. So whenever you are typing this letter D, it means that actually this number 100 is being stored in the memory of the computer. You will find that ASCII code is a very popular code, and almost in all over the world, this code is being used for converting many symbols on your keyboard into the binary form. So hopefully, friends, you have understood what we mean by the ASCII code. And in our later session, we will go for the discussion of the various logic gates. Thank you for viewing the session. Thank you all.